Hello, everybody. Welcome back. Today we are tackling 8.2. So today, special right triangles. Okay, so we got to start with some ground rules. Here's the rules you're going to need. Here is your two special right triangles. There's two of them: 30, 60, 90 at the bottom, 45, 45, 90, and those are the angle measures. Okay, we like these because they give us a little extra information. Okay. Starting with the 45, 45, 90, what we know is, again, the given being it has to meet those specifications. It has to be a right triangle, and it has to be 45, 45, 90. Okay? So it has to look like this. They have to give you that information. If you don't have that, then you don't have enough to solve it this way. Okay? If we do have a 45, 45, 90, then we know there's a relationship between the sides as shown right here. Okay? That relationship is the two legs are equal, obviously. We just call those S, side length, S. Okay? And then the hypotenuse, the opposite of the 90, we know that's just that S value times the square root of 2. Okay? Times the square root of 2. And I'll tell you now, today we're going to work on everything not decimals. So we're going to leave everything in its radical form with roots in it, because I think that's the harder way to do it. I think most of you would be able to take these things, plug them into a calculator, and get a decimal. Okay, the second one, 30, 60, 90, the shortest leg, we're going to call that S, that's just some value. In relationship to that, the longer side is twice that length, so 2 times whatever S is. And then finally, the hypotenuse is S times the square root of 3, so you just take that value times the square root of 3. Okay, obviously, depending on which side they give you, will change what you're actually working with. Okay, so number 1 here, we have a 45, 45, 90. Well, good. All right, so I know I'm working with this triangle. Okay, 45, 45, 90. I have an X and a Y. Those are what I'm trying to find, X and Y. And then I have a 3 down here. So what I look at, first off, I go here and I go, okay, it looks like I have this side. Well, that makes X pretty easy because S and S, those two are both just S. So if S is 3, then I know, without doing any work, that X also has to be 3 because that's our other side. That's our other leg. Okay? Now Y. Y, we look at it. Y is the square root of 2 times S. Well, like we said, we know S equals 3. So that means Y is just going to be 3 times the square root of 2. And like I said, we're going to leave things radical. So if you see the instruction, leave your answer as a radical, that's what it's saying. It's saying do less work. Don't multiply that out. Okay. If you wanted the decimal, obviously plug it into a calculator. 3 times the square root of 2. Okay. So there, we have our X and Y. We're done. We're done. All we have to do is match the information up. Okay. That's the easier one. When you're given the side first, usually it's going to be shorter. You're going to have a little bit less work. When we look at example 2, where now they've given us the hypotenuse. Okay, they've given us the hypotenuse. Okay, so we know that what that means is S times the square root of 2 is 8. Okay, S times the square root of 2 is 8. However, we want S. So if you think about it, S square root of 2, and I want S, how would I get to S? Well, it's like if I said you had 5S and I wanted S, what would you do? You divide by 5. Same thing here. We want S, so we're going to divide by the square root of 2. So what I have is 8 divided by the square root of 2. All right, kennel. Sorry about that. Dogs were going a little wild right there. Okay? So I'm solving for S. In order to do that, I divide by the square root of 2. Here's where it gets harder. Okay? You got to go back to your algebra brain a little bit. The whole radical and denominators. Even though we're leaving answers as radicals, there is a rule. Okay? You probably learned it last year. That rule is you can't have a radical in the denominator of a fraction. So I can't have this square root of 2 on the bottom. If we remember, though, it's a pretty easy fix. All you do, like every fraction, if I multiply the top and bottom by the same amount, I haven't changed its value. So same thing here. I look there and I go, what can I multiply the square root of 2 by to get rid of the square root? Well, any square root, if you just multiply it by itself, well, the square root of 2 times the square root of 2 is just 2. Makes the root go away, right? Throwing you way back to algebra. This was a long time ago, okay? Square root of 2 times the square root of 2. With radicals, you just multiply what's underneath. So what I end up with is the square root of 4, which is 2. Okay? Or you can just think if you multiply a square root by itself, the root disappears. Okay? Whatever I do on bottom, I have to do on top. So what I end up with here is 8 times the square root of 2, because I can't do anything with that, because they're both not radicals, if only one is. And I put that over, square root of 2 times square root of 2, over 2. Okay? Last thing here, I need to simplify any of the non-radicals that I can, and I have an 8 over a 2. Well, 8 divided by 2 is 4. So what I end up with for S is 4 square roots of 2. Okay? So that means, and the other nice part about this is, although there was more work here, even though there's an x and a y, we know those are the same length. Therefore, both x and y equal 4 square roots of 2. Okay? Now, of course, if I said, hey, write this as a decimal, you would have it really easy, because you would get to here, 8 divided by the square root of 2, you would get to this value, and you would just plug that into a calculator. It's a little bit harder when I ask you to keep it radical form. That's why I said we're going to work through those, so I can help you, so I can show you kind of what that looks like. Okay? So those are 45, 45, 90s. Remember, if you get S first, usually going to be the easier form. If you have the square root of 2S, then you have to work backwards. It takes a little more time. Okay? On to number 3. Now we're on to 30, 60, 90 triangles. Okay, so now we're dropping down to this triangle. Sorry, that was a horrible start. Okay, so on 3, I see I meet the requirements, 30, 60, 90, all the angles are there. Don't forget, little trick they could throw at you, I could have only marked 2 of the angles, right? Because then we could figure out the third and know, oh yeah, it's 30, 60, 90, okay? By the interior sum angle, or the interior angle sum rule, right? If I have a 30 and a 60, the only thing left is a 90 to make it 180. Okay, here I look and I go, this is where 30, 60, 90s get a little harder because it's not 2 equal legs. The legs are different. So I have to look and go, all right, is this the short side? Is this the S? Or is this the 2S? If we remember back to that rule about opposite angles, that there's a relationship. The smallest angle is 30, therefore the side opposite of it has to be the shortest side. Therefore, I know the 2 is S, and I forgot to mark this, that we want to find X and Y. Okay? So if S is 2, which, by the way, this is the easiest one you can get, is if I give you the shortest leg first. Okay? S is 2, then that means the longer side is just double that length. So in this case, the longer side, X, across from 60, is just double our short side. So I know X has to equal 4, because it's just double the length of 2, okay? And then Y, I look here and I go, okay, Y is just S, which we know, S is 2, times the square root of 3. And like I said, we're going to leave things as radicals, so this actually makes this problem easier. I'm just going to say, all right, 2 times the square root of 3, and we're done. There's my X and Y value just by using those shortcut rules, okay? Finally, and the hardest part probably, would be a triangle like this, where they throw some mix-up in there. They try and make you think back to your old rules, but not too terrible, because one, we really don't have to think that hard if we notice this first. If we notice on each small triangle, I have a 30 and a 90. Well, if I have a 30 and a 90, that only leaves one thing for up here, 60. Okay. The second way of thinking about it is, I have 2 base angles on the larger triangle that are the same, meaning these 2 outsides are both equal, because that's an isosceles triangle. And then I can keep going and go, oh, so that means if I have a right angle leading up to the vertex, so an altitude, which is my dashed line, if I have an altitude on an isosceles triangle, then what I've just made is 2 congruent, 2 triangles that are the same on each side, the smaller sides, okay? Therefore, I know I have 2 30, 60, 90 triangles, okay? What they've given us is this dashed line down the middle is 6. So if I think about it, I think, oh, really, I'm looking at 2 30, 60, 90 triangles, 6 being across from both 30s, okay, from both 30s. So that means 6 is my S, okay? 6 is my S. So then I have to look, and I have to go, okay, X. X is across from 60. That means X has to be my longer side. So I just double it. So I'd say, okay, X is going to be 12. And finally, Y is the hypotenuse. And I could have picked either one of the hypotenuses because they're the same. y is the hypotenuse, so I just take s times the square root of 3. So y is 6 square roots of 3. And I'm done. Okay? So that's how we're going to use the shortcuts. Make sure, don't overthink it. Don't trap yourself here. All we're doing is taking a template and making sure we're matching up the pieces. And then, like I said, for most things, I want to leave it in radical form. And that's what I'm going to ask of you in your homework. Use these rules. Make sure you're paying attention to which side's the biggest mistake I see is, especially in the 30, 60, 90 triangle, okay, or this example, the first or the second one. You'll notice people putting the wrong piece with the wrong spot. So like I give you the longer leg and you put it down as S. And then all of a sudden your triangle's all the way off because that was supposed to be 2S. That was supposed to be the larger side and you're supposed to work backwards, divide, do all that good stuff. Okay, so make sure you're putting things in the right place. You know, use your angle rule. So if it's across from 30, it's the smallest side. If it's across from 60, it's the larger side. If it's across from 90, it's the hypotenuse. It's pretty easy on the 45, 45, 90 because both legs are the same length. It's an isosceles triangle. Okay, that's what I got for you for today. We'll come back with homework on Wednesday. But for now, make sure you got this down. Ask questions if you got it. Otherwise, have a great day.